Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about machine learning application in recommendation space. This episode is based on a tech blog titled How Instacart Uses Machine Learning to Suggest Replacements for Out-of-Stock Products, written by their engineering team. You can find the link in this episode's description. Throughout this episode, we will explore this topic from both the business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Instacart is one of the largest grocery delivery platforms in North America. It operates across more than 14,000 retailer locations and serving millions of customers. The company partners with major grocery chains like Costco, Kroger, and Safeway, and its marketplace spans hundreds of thousands of unique selling items. One of the biggest challenges in grocery delivery is stock availability. Unlike digital products, groceries are physical goods, and inventory data isn't always perfect. Sometimes an item that appears available in the app turns out to be out of stock when the shopper is actually in the store. That's why Instacart asks customers upfront about acceptable replacements to guide shoppers and make sure customers still get what they need. Getting replacements right is critical. If the wrong substitute is always presented, customers can quickly lose trust in the service. But if the replacement feels natural, say a different brand of milk or a slightly smaller pack of strawberries is always presented, this preserves the shopping experience and keeps customers happy. From a business perspective, this experience directly affects customer satisfaction, retention, and eventually the company's revenue. So the motivation is clear. Instacart needs a smart, scalable way to recommend suitable replacements for potential out-of-stock items. Now that we've understood the business problem, let's look under the hood and see how Instacart tackled the challenge behind the scene. At a high level, the team faced four major technical challenges. The first one was that they call head versus tail problem. Popular products have plenty of data from past orders, making them easier to model. But the rare or newly introduced products don't. That means the system has to rely mostly on catalog attributes like names, sizes, and dietary tags. Balancing these two extremes is key to maintaining a good customer experience. The second challenge came from the diversity of retailers. Using one global name across all stores risks bias. A replacement that works for Costco might not even exist at a smaller local chain. The model needed to adapt to each retailer's unique inventory and customer preferences. A third challenge is that there was the issue of availability. Even the best ranked replacements might also be out of stock. The system needed to automatically fall back to the next best option without drifting too far from what the customer originally wanted. And finally, the team had to handle highly personalized customer preferences, things like brand loyalty, flavor, and package size. Capturing these nuances accurately is essential to deliver a great experience. To address these challenges, the team designed a system built around two main machine learning models. One is based on catalog data and can generalize across all products. The other is powered by customer engagement data, tailored for products with plenty of user interaction. Let's look at the catalog-based model first. This model follows a funnel-based approach with two stages created. The first stage is retrieval, the second stage is ranking. In the retrieval stage, the system identifies potential replacement candidates for a given item. Instacart's catalog data includes millions of products, so comparing every possible pair would be computationally impossible. Instead, the team used heuristics to narrow things down, and they measuring product name similarity using Levinston distance, and factoring in product popularity as well. This approach works pretty well. The team found out that more than 95% of the replacements chosen by the shoppers are found within these candidate sets. Once the candidates are retrieved, the ranking stage begins. Here, a supervised deep learning model predicts how likely customers are to approve each candidate as a replacement. This model learns from product attributes and real customer interactions, using a point-wise ranking approach that's simple and efficient to integrate with business logic. To keep things fresh, the scoring pipeline is updated on a weekly basis, allowing new products to enter the system and ensuring continuous coverage is there. While this deep learning model works well in most cases, it struggles with products that are replaced very frequently, which are the head items. That's because the above model is designed to learn those generalized patterns rather than memorize specific proven pairs. To solve this problem, the team introduced an engagement model optimized for memorization. This model looks at historical customer engagement data to compute approve rates for replacement pairs. It adjusts for confidence intervals and pre-computes scores for pairs with enough replacement history. So if customers constantly approve swapping one brand of yogurt for another, the system learns to prioritize that pair automatically. The final recommendation system is an ensemble of these two models. Each product pair gets a combined score. The engagement model carries more weight when there is abundant historical data, while the deep learning model based on catalog information dominates when data is sparse. The team fine-tunes these weights to maximize both offline metrics and live performance. While the two-model approach worked in principle, the team noticed a major issue. This system was biased toward universally available products, like big-name brands, instead of focusing on what each retailer uniquely offered. The root cause of this problem was in the model's simple schema, which it only includes a source product and a replacement product, and using that as a prediction. Since brand name items appears across multiple retailers, they were unfairly prioritized over store brands. That led to customer complaints, especially when replacements ended up costing more than the original items, which is not kind of the experience the shoppers expect. To fix this issue, the team made the system retailer aware by adding retailer ID to this schema. The engagement model was also updated to calculate approval rates for each retailer individually, reflecting localized customers' preferences. This made the recommendations more relevant and fair. Store brands were suggested more often, and replacements better matched the customers' expectations and budgets. The online A/B tests also confirmed the impact, showing statistical significant gains in replacement success rates and customer satisfaction. Now, we've discussed both the business problem and the technical solution. Let's wrap it up. In this episode, we explored how Instacart uses machine learning to recommend replacements for out-of-stock products. This is a challenge that sits at the heart of the grocery delivery experience. On the technical side, we saw how the team's two-model approach works. A deep learning model captures general product relationships across the catalog, while an engagement model learns from customer behavior to personalize these recommendations. Together, they help Instacart deliver recommendations that are accurate, relevant, and efficient at scale. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.